Good morning. This is the second part of my webinar. You have already seen Saudi silica sand resources and Saudi silica sand potential, and this is the second part on Saudi quartz. I will discuss the resources as well as potential of Saudi quartz. I hope you all know that quartz is the main mineral of silica. What are the common commercial resources of quartz in Saudi Arabia? In Saudi Arabia, quartz occur in form of quartz veins. Quartz veins are narrow, few meter wide and 100 or 200 meter long, sometime more than 200 meter. So these quartz veins are not important commercial resources of quartz in Saudi Arabia. This I am saying based on the exploration we have done in last 10 years. However, I must say that there are still great potential to find better and bigger resources of quartz because not much work has been done on quartz. Quartz also occur in form of pegmatite, and these pegmatites includes both zone pegmatites and homogeneous pegmatites. Homogeneous pegmatites are the mixture of quartz and feldspar, and in Saudi Arabia, homogeneous pegmatites are mined for feldspar instead of quartz. Nobody has made attempt to separate quartz from feldspar on the commercial scale. The most important, in my opinion, the most important source of quartz in Saudi Arabia are the zone pegmatites. These zone pegmatites has a core of quartz in form of a hill or mountain, and that is surrounded by pink feldspar or white feldspar, and in few cases some other minerals. So zone pegmatites offer investment opportunities, mining opportunities, selective mining opportunities for mining feldspar as well as quartz. Quartz is also found in form of quartzite. In Arabian Shield area we have metaquartzite, and in cover rocks we have orthoquartzite. We have quite big source of orthoquartzite in Al Majma area near Riyadh. Once again, it has not been explored on a large scale, on detailed scale. There is a small quarry of orthoquartzite, and this orthoquartzite, unfortunately, it has been used for the construction purpose instead of some high-tech application. It has also been used for the production of silicomanganese in Saudi Arabia. Okay, let's discuss quartz zone pegmatites, which I told you the most common quartz occurrences, quartz veins and homogeneous pegmatites. This is another thing which we start calling quartz floats. I don't know if this term is used anywhere else, so I will explain you what are the quartz float and what is their potential in Saudi Arabia. Okay, this is the photograph showing a zone quartz occurrence in Wadi Bua. You can see this is the central body of quartz in form of a mountain, and it is surrounded by feldspar, pink feldspar and white feldspar. This quartz is sitting on the top of granite. This is another smaller body of quartz in Qasim area near Arras. Once again, it is a smaller body as compared to Wadi Bua. In our exploration, Wadi Bua was the biggest resource of quartz, about 750,000 ton, although it is not sufficient to produce silicon metal. On the right hand side are this quartz in Qasim area. It is much more smaller than Wadi Bua quartz. Quartzite. This is the thin section under microscope showing the quartzite, how the quartzite occurs. This is, by the way, this is orthoquartzite. In fact, orthoquartzite is a kind of sandstone. The difference between sandstone and quartzite is much more stronger and the binding material which bind the quartz grains together in quartzite, it is silica. It is siliceous binding material. So let us discuss high-tech application of quartz and quartzite. Okay, try to understand this, what we can produce from quartz. For quartz, we can do upgrading, we can produce high purity quartz. High purity quartz is used in quartz glass and other products, very high quality, very high tech products. In the world, there is only one producer, Unimin, North Carolina, which produce 90%, I will say more than 90% of the world demand is produced by Unimin, North Carolina. On the other hand, quartz can be upgraded to produce EMC fillers. This is epoxy molded compound fillers. It can be used in engineered quartz stones. It can be used to produce solar silicon by direct reduction process. Quartz produces silicon metal, which is called metallurgical grade silicon, and it needs a reduction process, and silicon metal is used to produce trichlorosilane, and trichlorosilane is used to produce solar silicon, polysilicon. Silicon metal is also used to produce silicon tetrachloride, and silicon tetrachloride produces fumed silica, a powdery material, a powdery silica of micron size, even finer than micron size. Silicon metal is also used to produce dimethyl dichlorosilane, and these dimethyl dichlorosilanes are used to produce a large number of products, comes under the category of silicones. And fumed silica is used as a filler in the production of silicones. The silicones include rubbers, plastics, elastomers, adhesives, cementing material, etc., etc. Silicon metal is also used in production of aluminum alloys. Two main products of quartz. Quartz is used to produce high purity quartz. It's called high purity quartz. As I told you, there is only one big producer of high purity quartz in the world. That is Unimin, North Carolina. So, is there change in the chemistry when we produce high purity quartz from quartz? No. Quartz remains quartz. Silica remains silica, SiO2. There is no change in the chemistry. The definition of high purity quartz is that we remove the impurities from the quartz and convert ordinary natural quartz into high purity quartz. And the maximum impurity levels in the high purity quartz does not exceed more than 25 parts per million. So the purity of the high purity quartz is silica percentage is more than 99.998%. High purity quartz is produced by intensive processing of natural quartz. We remove iron, we remove all other impurities by crushing, grinding, screening, magnetic separation, froth flotation, and very intense. The processing is very intensive. But also there is a addition in the value. So the high purity quartz is added value product of quartz. An ordinary quartz may be sold in the market at the $100 per ton, but high purity quartz can fetch a price more than $5,000, even $10,000 per ton, depending on the impurity, nature of impurities, and the content of impurities. The high purity quartz produced by Unimin is called IOTA. They produce IOTA standard quartz, and the IOTA standard, the maximum impurity level is 25 parts per million. Silica percentage in the high purity quartz, as I told you, is 99.998% or better. High purity quartz cannot be produced from silica sand or cannot be produced from quartzite. To produce high purity quartz, we need lump quartz. Let's see, silicon metal. That silicon metal, it is called metallurgical grade silicon, or we can call it MgSi. So these are the two main products of quartz. On the left hand side, high purity quartz, on the right hand side, silicon metal. Silicon metal, there is change in chemistry, yes. SiO2, which is quartz, SiO2 change into Si. So we remove oxygen. The process of removing oxygen is called reduction. And this reduction process on the commercial scale, it costs at least $300 million or $350 million. And a greenfield plant produces about 30,000 ton silicon metal. And this metal need quartz as a feed material. The specification of quartz, in that case, to produce silicon metal, quartz is not very high purity. It is about 98.5% silica, but there is restrictions on the impurities. We have to check, say, the aluminum content, titanium content, alkali contents. So we cannot produce silicon metal from any quartz. There is a particular quartz with a particular chemistry that can be used to produce silicon metal. And there is a size. When we break the quartz should be in definite size. So for the production of silicon metal, we need the chunks of quartz ranging between 3 cm to 15 cm. That is why silicon metal cannot be produced from silica sand, because silica sand is just 2 mm and smaller. Yes, the quartz used to produce silicon metal should be strong enough physically as well as thermally. Why? Because if it is not strong enough, it is not mechanically strong, it will keep breaking during mining, during transportation, during processing, during handling. So the size will reduce. So the quartz should be strong. It should be thermally strong. What does it mean, thermally strong? It should have thermal strength. When we start heating quartz together with the source of carbon, this carbon will take out the oxygen from silica and leave silicon. So the quartz should not start breaking at high temperature. If quartz has some impurities like muscovite mica, it will start breaking down and the size will decrease. That's why we need a quartz with thermal strength, and it should not break unless it starts melting. Other raw material needed, yes, to produce silicon metal, we need quartz. In addition, we need a source of carbon. Normally, it is petroleum coke, pet coke. And we need wooden chips. We need some other materials. But the main thing is quartz. Temperature reaction is 2800 degrees. Silicon metal can also be produced from quartzite, but not from silica sand. Main application of high purity quartz and silicon metal. Let's see, the high purity quartz is used in optic fibers, in the manufacturing of optic fibers. It is used in quartz crucible for making monocrystalline silicon. So when we produce solar grade silicon from the metallurgical grade silicon, this is polysilicon, this is multicrystalline, and we have to, in some cases, we need to change it to monocrystalline silicon. So this polysilicon should be melted. So for melting polysilicon, we need the crucibles, and these crucibles are made up of high purity quartz. If these crucibles are not made up of high purity quartz, there will be some impurities added into the silicon during the manufacturing of monocrystalline silicon. High purity quartz is used in optical glass, lenses for telescopes, microscopes, very high quality lenses, quartz glass for laboratory wear, high temperature lamp tubing. It is used in electronics, It is used in epoxy molded compounds, EMC fillers, for the encapsulation of the electronic components. It is also used in engineered quartz stone. On the other hand, silicon metal is used. All the silicon metal produced in the world, 10% of the silicon metal is used for polysilicon manufacturing. Mostly, I will say majority of it for the solar grade silicon, solar grade polysilicon, and very small, relatively small percentage for the electronic grade. 40% in aluminum alloys, 50% in silicone production. Silicones are the compounds. These are elastomers, plastics, adhesives, binders. A large number of products comes under the category of silicone. The use of silicon in making polysilicon and silicones is via silicon chemicals. So we cannot directly use the silicon in the manufacturing of polysilicon or silicones. We have to produce some silicon chemicals first. Let's see. High purity quartz. How we make high purity quartz? We need natural quartz. We do upgrading, very intensive upgrading, and we convert this natural quartz into high purity quartz. So high purity quartz, after melting, produce quartz glass. What happened in Saudi Arabia? We tried to produce high purity quartz from our Saudi quartz, but it was unsuccessful. The reason was that Saudi quartz, I'm not talking about all because we have not tested all the quartz in Saudi Arabia. We have tested 6 quartz occurrences in detailed scale. There are much more quartz occurrences which need to be tested. So what happened when we start removing, you see all these colors show the impurities in quartz. So the yellow, orange yellow is aluminium, then red is iron, blue is sodium, green is potassium, then purple is lithium, and this light gray color is titanium. So after crushing, we have these impurities. After classification, impurities removed. After scrubbing, impurities removed further. You can see from bottom to top. After magnetic separation, further impurities removed. Ultimately, we reach to the chlorination on the top, and you can see almost all the impurities removed, only the aluminium left. Only the aluminium left. So what happened? That in this Saudi quartz, this aluminium become part of the body of the quartz, because the atomic radius of silicon is similar to aluminium. So during the formation of quartz, aluminium atoms jump inside the quartz and take the place of silicon and kick out the silicon. So the aluminium become part of the body of the quartz and it cannot be removed. You can see in the table down, we started after crushing, aluminium was 274 and we remove it. At the end, 75 parts per million is still there. We started potassium from 105 parts per million and we have removed all of them, and in the final product it was only 0.2 parts per million. So this was the problem. We were not able to produce high purity quartz. But there, as I told you, there are still chances, there are loss of occurrences of quartz, and we have to test them. If we produce high purity quartz in Saudi Arabia will be the 3rd country to produce high purity quartz. There's another thing. It is not what quartz look like. See, on the left hand side, WBCA, this was Wadi Bua quartz, and on the right hand side you can see ADD2. The impurity level is small, it's about 50 parts per million or 60 parts per million. In the middle, JAA1, the impurities are 350 parts per million. But after the processing, the worst quartz, which was visibly worst quartz right in the middle, which has impurity levels of 300 ppm, it was improved to 0.2 parts per million. On the other hand, the other quartz, they reach to the same level. What I want to say that it is not that how quartz look like. It depends how quartz can be processed. So a dirty quartz can be processed nicely. A nice looking shiny quartz cannot be processed. So there is always possibility. So we have to do the characterization of quartz, optical characterization, and then we have to do the testing of quartz. Okay. So I hope you understand that it is not how quartz look like. Maybe it is dirty looking quartz or very shiny quartz, but it can take good processing or less processing. Important. What is high purity quartz? Again, I think you understand that high purity quartz is a manufactured quartz, is a processed quartz, it's a value added quartz that can be used in a large number of high tech applications. Again, the demand of high purity quartz in the world is not much, it is about 50,000 ton only, but the value is very high. As I told you, an ordinary quartz may be sold at the price of $100 per ton, but we can fetch the market price of high purity quartz depending what kind of impurities are left and what is the total amount of impurities. We can fetch a price of $10,000 per ton. Manufacturer, there is one main manufacturer, Unimin, North Carolina, and they don't want any competitors. So the second manufacturer, which was Norwegian Crystallite, the Unimin purchase them, they buy them, and they form a new company which is called the Quartz Corporation. So Unimin has no competitors now. In making silicon metal, metallurgical grade silicon, we need big quantities, large quantities of quartz. But for making high purity quartz, a small resource of quartz, about 100,000 ton, will be sufficient, because Saudi Arabia will enter as a new entrant into this market, and maybe Saudi Arabia will start from the 10% of the total market. They will get the share of 10%. So 10% is just 5,000 ton. For 5,000 ton, we need for 20 years a resource of 100,000 ton will be sufficient. World demand I have already discussed. Iota quartz is the quartz standard produced by Unimin. Purity and impurity level we have already discussed. Processing involved, it is very intense processing, and there are only few companies, research companies, who can do all this processing. In Saudi Arabia, we have established, in Saudi Geological Survey, I have established Mineral Beneficiation, MRBC, Mineral Research and Beneficiation Center, where we have some facilities but not all. High purity quartz applications include making crucibles for converting polycrystalline silicon into monocrystalline silicon. We need the crucible for melting the polysilicon. Fused quartz glass for high-tech application. Downstream products are telescopic lenses, laboratory glass and tubes, high temperature lamp tubing, optic fiber for the telecommunication and lighting applications. Market price I have already discussed. Saudi potential, there is great potential because not much not many quartz resources has been explored. In the south, almost all quartz is still there. We still have to know about quartz in Saudi Arabia. Saudi Arabia as a new entrant in high purity quartz production. We don't need a large big quantity of quartz. A small resource of 100,000 ton will be enough as long as it can be upgraded to high purity quartz. Potential Saudi share I have already discussed. Okay. So these are some high purity quartz products. On the left hand side, this is high purity glass. On the right hand side, optic fibers. These are crucibles. And this is high purity quartz in the kitchen surface. This high purity quartz not as high purity as it is used in the electronics and other things, but it's still high purity. It can be used to manufacture quartz stone that is used in the kitchen furniture, in bathroom vanities, in slabs and tiles in the commercial buildings. So this is slightly lower grade application of high purity quartz. You see, these are the slabs produced from high purity quartz, and these are called quartz stone, engineered quartz stone. Okay, many people are still confused between silica sand and quartz. Silica sand and quartz are used for different applications, but sometimes if we don't have silica sand, we use quartz. In European countries where there is no silica sand, they crush the quartz, they crush and grind and screen quartz to produce sand-like substance, sand-like material for making glass. But fortunately, Saudi Arabia has abundant resources of high quality silica sand, so we save the cost of crushing and grinding because it naturally it is sand size. By the way, the definition of sand is sand, the terminology of sand, the term sand is used for the particle size which are between 2 millimeter to 0.06 millimeter. It is not commercially viable and wise to use lump quartz in Saudi Arabia to manufacture glass. Why? Because we have abundant natural silica sand, filler, silicon carbide, silica chemicals. For all these applications, it is wise, it is viable to use Saudi silica sand resources, not quartz resources. Quartz resources, we should keep it for high-tech applications, for manufacturing silicon metal and downstream. Some other countries, I have already explained it to you. It is true that we need high quality silica in some products such as optical glass, grade 1 and grade 2, and high purity silica fillers, EMC fillers, which require quartz because silica sand does not reach to that required purity levels. I will say that probably silica sand will reach to that purity level, but it will be quite expensive. So it is for some application we prefer to use quartz. Okay, I say uses of silicon metal. When I say silicon metal, I mean metallurgical grade silicon, MgSi. So MgSi, metallurgical grade silicon, is converted into trichlorosilane, which is used in solar polysilicon. Metallurgical grade silicon is changed into silicon tetrachloride, which is used to produce fumed silica. Metallurgical grade silicon used to produce dimethyl dichlorodimethyl silane, which is used to produce silicones. Metallurgical grade silicon is also used with aluminum. It produces aluminum alloys. Quartz for silicon metal manufacturing. In addition to the chemical specification and crush size range, the quartz should have required mechanical and thermal strength. I told you the reason, because if it does not have thermal and mechanical strength, the quartz will start breaking down during the handling, during transportation, during heating, and the size will reduce. We need a size between 3 centimeter to 15 centimeter. For making silicon, by the way, different manufacturer they use different sizes, but they are large sizes. For making silicon metal, quartz cannot be upgraded other than washing and salting. I hope you understand that. For upgrading, we have to crush the quartz, and for making silicon, we cannot crush the quartz below certain size limit. So what we can do? We can just wash it. We can do the optical sorting or sensor based sorting or hand sorting. There is restricted impurities: phosphorus, boron, iron, aluminum, calcium and titanium. So these are the restricted impurities. I will give you the specification of quartz which is needed to produce silicon. Iron content maximum 0.04% to 400 ppm. Alumina Al2O3 0.2% to 2000 parts per million. This is also maximum. On both sides is maximum. On the left hand side I am showing the percentage, on right hand side is parts per million. Calcium oxide should not exceed more than 100 parts per million. Titanium oxide should not exceed more than 50 parts per million. Size quartz crush should be 12 centimeter, 2%, should not exceed more than 2%, greater than 15 centimeter, 0%. So it should be around 15 by 4 centimeter, minimum 96%, and also need thermal strength and mechanical strength. Can we use silica sand instead of lump quartz? No. The reason is very clear to you. Actually, you will see many people, they describe that yeah, silica sand can be used, but until now, no commercial manufacturer is able to use silica sand. You can see the sketch showing the production of silicon metal. On the left hand side, in the hopper we pour silica, that is quartz, crushed quartz, and carbon, source of carbon, which is low sulfur petroleum coke, pet coke, which is heated by the electrodes at 2800 degrees centigrade, and then oxygen has been taken out, and there is a reaction between silicon and carbon, and the carbon take out the oxygen in form of carbon dioxide, which goes out. And at the bottom you can see the silicon. First it is molten, then it is solidified, and after that it is crushed into two different sizes. Prices of metallurgical grade silicon. These are little bit old prices, but they are mostly consistent. So this is a table showing the prices in China, FOB prices in India and Russia. There are different kind of silicon metal produced. Silicon tetrachloride. So it is fumed silica. It is produced by fumed silica burning silicon tetrachloride with oxyhydrogen flame and synthetic fused silica hydrolysis of silicon tetrachloride. So in this way silicon tetrachloride is produced. So from quartz to silicon metal, and from silicon metal to silicon tetrachloride, and from silicon tetrachloride we produce fumed silica, which is a powdery, white powdery substance. And fumed silica, it is finer than micron size. Actually it is nano size particles. Fumed silica is an amorphous silica produced from burning silicon tetrachloride in a oxyhydrogen flame at 1800 degrees centigrade. By the way, this silica is different. Quartz is also silica, but this fumed silica is amorphous silica. Quartz, the feed material, it was crystalline silica. Very tiny droplets of amorphous silica produced in this reaction, which collides and fuse together with one another to form branched chain like structure, three-dimensional particle size, which are agglomerated together, and after that we can grind them. Fume silica particle size is about 5 to 50 nanometer. The particles have surface area of about 50 to 60 square meter. I hope you understand that if we put 1 gram particles, which is not possible, 1 gram particles of fumed silica side by side, they will cover an area of 60 or 50 square meter, and the bulk density is 160 to 190 kilogram per cubic meter, whereas the bulk density of silica sand was bulk density of the quartz was 2500. Sorry, it was the density, the bulk density was 1500 kilogram per cubic meter. These are the different uses of fumed silica. It is used in adhesive, sealant, batteries, catalysts. There are large number of uses of fumed silica. Let's see. Silicones. It's a long, lengthy topic. I will discuss it very briefly. So, metallurgical grade silicon converted into dichlorodimethyl then it is converted into siloxanes, and siloxanes converted into silicones. The word silicon is used for a variety of polymers with repeating silica oxygens, silicon oxygen silicon chain, the backbone of silicones. Organic groups such as methyl CH3 can be attached with these chains. How dimethyl dichlorosilane monomers are produced? We need silicon metal, that is metallurgical grade silicon, and we need hydrochloric acid, and we need methanol, and we need energy. Methanol and hydrochloric acid will produce methyl chloride. Methyl chloride is passed over the fluidized bed of powdered silicon metal and produce dimethyl dichlorosilane. This is the structure of dimethyl dichlorosilane. So, let us see how the silicones are produced. We need quartz that produce silicon metal, and silicon metal will produce dimethyl dichlorosilane. Dimethyl dichlorosilane will produce siloxanes. Siloxanes will produce silicon fluids, and silicon fluids will produce silicon products, which are plastic, rubber, elastomers, cosmetic, resins, epoxy, sealants, adhesive, lubricant, weatherproofing materials, etc., etc. So, I am not going to discuss all the process of this, but I want to say that it is a very expensive, it is energy intensive process. However, Saudi Arabia needs the production of silicones because these silicones are directly related to the construction industry for weatherproofing, waterproofing, resins, epoxy, sealants, you just name it. So, more than 7,000 products are manufactured from silicon fluids for use in automobile industry, aerospace industry, construction industry, cosmetics, petrochemicals, oil and gas, coating, adhesive, sealant, food, feed, pharmaceuticals, etc., etc. The whole chain, the value chain, the whole investment from quartz mining until the production of silicones is about $1 billion. What products are formulated from siloxanes? Saudi potential market related to the construction sector, rubbers, coatings, sealants, emulsions, water repellent. Who are end users? Construction industry, decoration industry, healthcare, transportation industry, industrial sportswear, oil and gas refining, drilling chemicals, foams, etc. There was a company, no more, Project Management Development. They made the effort to produce polysilicon in 2008. Now we have news that they are producing polysilicon in Malaysia. Why? They had joint venture with Norsen, Norway in 2008. It was the lengthy procedures, red tapes, and finally the Norsen left, and the PMD start manufacturing polysilicon in Malaysia instead of Saudi Arabia. Idea International also delayed repeatedly its project. Now Idea is planning to produce 20,000 metric ton solar grade silicon, a joint venture with world known REC. The solar silicon will be produced using most modern technique, FBR, fluidized bed reactor. However, this news is also a few years old and nothing happened between these last few years. The Polysilicon Technology Company, PTC, Chemical Development Corporation, has taken some steps recently in developing polysilicon manufacturing plant, and they are hopeful to start the production next year. I think they have already produced the production, and they are importing trichlorosilane into Saudi Arabia. Instead of producing their own trichlorosilane, they are importing. Polysilicon. I think I should not discuss this because we already have polysilicon experts here. Let's say I will go very briefly. We need quartz, need crushing of quartz, 3 to 15 centimeter, washing and salting, then we have silicon metal. On the other hand, we produce high purity quartz. So what I want to show you that these two industries are very well integrated. So silicon metal convert into trichlorosilane, various processes, and then we produce solar polysilicon. On the other hand, high purity quartz produce direct. We can also produce polysilicon by the direct reduction method, which nobody has done yet. So instead of producing silicon metal and purifying silicon metal, what we are doing here, we are improving the quality of quartz. So we are producing high purity quartz, and then we are pelletizing it with a cementing material which is organic. So during the heating it will not break, but the organic cementing material will evaporate. So it is called direct reduction method. I don't know if anybody has done it on the commercial scale yet, but it has been done in Norway on the laboratory scale. High purity quartz produces high purity quartz crucibles, and the solar polysilicon goes into those crucibles and they produce monocrystalline silicon. So this is how all these two industries are very well integrated. So in addition to trichlorosilane, silicon tetrachloride is produced and dimethyl dichlorosilanes are produced. Silicon tetrachloride produces fumed silica, dimethyl dichlorosilane produce siloxanes, siloxanes produce silicon fluids, and silicon fluids produce not silicon products, I am sorry, these are silicone products. So conclusively, there are many resources of silica, sand and quartz in Saudi Arabia. In last few years, we have done most of the work to make sure that these resources are not misused. We have done this work. I will not discuss it, but there was some misuse initially. Presently, Mineral Strategic Committee is finalizing the mineral strategy for Saudi Arabia. But again, I think I should inform you that this committee has already completed the strategy, mineral strategy of Saudi Arabia, and part of it has been released. There is a great demand for silicones, especially in the construction related industry in Saudi Arabia. All hurdles should be removed which are holding back the long awaited silicon metal manufacturing and its downstream, such as solar silicon and silicones in Saudi Arabia. Glass manufacturers should investigate and conduct market studies to start production of processed float glass in Saudi Arabia. Float glass is produced in Saudi Arabia, but the processed float glass, for example, low E glass, is not produced yet. And then I hope that float glass manufacturers, they will produce solar glass as the demand arises. So I think that's it about quartz. Okay, thank you very much.